Hey everybody, I'm James and welcome to the Esprit Tech live stream episode 8. Today we're going to be talking about helicopters. I want to just a little bit of discussion about that side of the hobby, a little bit about the machines, and then of course we're going to go into some programming. Probably going to be some questions still out there when we get done because we can't quite cover all of the flybarless systems and all of the accessories and things that are out there. But when we're all said and done, if you have questions, you can always reach out. Don't forget to, while we're doing the live stream, you can reach out to me on the comments. We do have a little bit of help in answering the comments. Anything that I see that doesn't get answered right away, I apologize, but I will try and keep up with the comments. Hey, what's going on, Warbird? Good to see you. Well, see you is a relative term. And speaking of that, before we get into the topic, I just want to reach out to you guys and let you know. We know a lot of you guys, the country's starting to go back to work, and so a lot of our friends and our customers are going back to work, and we know a lot of you guys aren't. And we know that this hobby, this passion of ours, is a great distraction from everything that's going on. And we just wanted to let you guys know that we're unbelievably proud to be able to still be here and still supply the things that you're needing and still be able to answer your questions and kind of be that distraction for you during this, because we all need it. Guys, I hope everyone out there is healthy and doing well. Don't forget, especially while things are like they are, don't forget to be nice. Everybody's stressed out. Everybody's at their limit. Just be the best you that you can be. Now that rant's over with, we'll kind of get into the topic at hand. RC helicopters. When I got back into the hobby, I was kind of involved in the hobby with my grandfather when I was young, and many years later, I decided to get back into the hobby. I wanted to fly a helicopter. I had seen them. I thought they were the coolest thing in the world from when I was younger, and so I went to my local hobby shop, and I went up to the counter and I said, "Hey, I want to fly helicopters. What do I need to buy?" And he says, "Well, what do you fly now?" And I told him, "Well, I've never flown anything. I don't fly airplanes. I had driven RC cars, and I had flown airplanes years before." And he said, "Well, do you have a simulator?" And I said, "No, I don't have a simulator." And he said, "Okay, well, here's what I'm going to do. I'm going to walk you over and I'm going to let you fly." So he walks me over. They've got a nice real flight set up in this retailer. And he sets me up on a helicopter. he says, go ahead and mess around on here a little bit. The red button's your reset, and I'll come back over and check on you. So I jump on there thinking, this is going to be no problem, no big deal. And immediately, we do what we all do, and we start crashing. Well, he comes back over in a few minutes and said, what do you think? I said, oh, this is awesome. He said, well, you've spent over $1,000 so far in parts. Can I show you an airplane? And I think for a lot of people, that's the big distraction or big deterrent from getting into the helicopter hobby. Everybody looks at it and they hear people say how hard it is and how you spend so much money you're going to have, but I don't think that's always going to be the case. So long as you're thoughtful in the process and you buy the right stuff to start with and you do the things that you're supposed to do and you take the baby steps, I think it's an amazing hobby. I've been, like I said, interested in it for as long as I can remember. My grandfather was an RC modeler, built and flew airplanes and competed, and I remember when I was a kid, in his basement was a very early helicopter model in pieces, and it was his one and only foray into that side of the hobby. He had built a machine, he had gone out, he had started it, taken it off the ground and destroyed it, and he had never touched it again. And I remember even then him telling me how difficult it was. As I went into this and prepared to make this video, I started doing some research because I was thinking about that old machine on the shelf. And I really fell down the rabbit hole with this. If anybody has a lot of time to kill and is super geeky and technical and loves this stuff as much as we do some research on the history of model helicopters. You will be blown away by what you see in there and what the early pioneers in our hobby went through to get us to where we are today. Those of you who are recent into the hobby, the electronics that we have now and the things that the machines are capable of now are just unbelievable once you look back and see where we came from. I did a little research and I pulled up some stuff that was kind of cool while I was doing this. The first kind of recorded model helicopter flight, controlled helicopter flight, was actually in 1958, and it was a project taken on by Lockheed Martin. It was not designed for recreation. It wasn't a model helicopter as we would think of it. It was a proof of concept model. It was built to test two new theories in helicopter design, one of which was the rigid rotor head. The other was gyro control system, mechanical gyro control system. The helicopter was able to hover for a small period and then maintain forward flight under control. They didn't work on the hover part of it because they knew it could. This was just to prove the concept. This sparked a lot of people's imaginations because that was 1958. 2 years later, an article appeared in the RC magazines at the time about the flight and about the vehicle that done it, including a picture. That kind of sparked off some of the early pioneers in the sport. The biggest of which, of course, everybody would probably refer back to would be Dieter Schluter, Dr. Schluter, kind of pioneer in the industry, in the helicopter world, and his interest was sparked by that early achievement from the guys at Lockheed. Schluter was always interested in helicopters, always wanted to model the helicopter, but always believed, at least in the beginning, that it was far too complex a vehicle to be able to model. And in a way, he was correct. Most hobbyists at the time were working in wood and dope covering and materials of that nature, and you just could not build a model helicopter with those materials and those technologies. And so it was a lot of years later that model helicopters, like we would know them, or at least the early predecessors to those, were going to be able to fly. In 1965, John Burkham drew drawings which were very similar to what we would call a modern RC helicopter, a model helicopter. Of course, he never built the machine. There were only a few people known in history to have built machines from that plan. The one person who was known to have finished that model admitted pretty quickly that without being a qualified machinist and an engineer, the modeler could never build a helicopter. 1967, Schluter finally built his first flying working prototype. One of the things that was apparent in that is that he was really kind of moving in the wrong direction. Dr. Schluter, being the engineering mind that he was trying to solve the problems that existed in full-scale rotor-driven aircraft or rotor-lift aircraft, and he didn't have to. So he went for the overcomplicated route, and the more he experimented in the early days, the more complicated the machine got, and it kind of fell apart on him. It really wasn't attainable with the technology of the time. There were two kind of schools of thought. You had the design engineers and the practical engineers approaches, which is a more is more and less is more approach to the hobby. And Schluter in the beginning was moving in the wrong direction and trying to get more and more complicated. They were using a bell bar. They were doing a lot of things that kind of kept the machine from working at our size and our Reynolds numbers. So in '68, the following year, John Burkham, who had drawn the plans a couple of years before for what would have been a fantastic helicopter, actually sustained a record with his first machine that he actually built on his own. It was a sustained flight record at 6 seconds, which is, at that time, pretty amazing. One of the things that was noted everywhere when I did the research was that flight wasn't really a controlled flight. It was more of an uncontrolled hop or hover. He was using a large weight-attached bell bar, which meant the inputs that he put in for cyclic were immediately muted by the bell bar, and he did not have control of that flight. But it did lift off, did sustain a hover for 6 seconds, and did set down in one piece. That was technically only an official record because it was not submitted by Burkham. It was submitted by the AMA at the time to the FAI. There were other records, including Dr. Schluter's, who would have been longer had they been submitted correctly, but they were not. 1970, things completely kind of changed in the industry. Schluter actually showed for the first time his Bell Cobra helicopter. It was the first fully controllable, fully attainable model helicopter. It was also the first model helicopter to be kitted, although at that point in 1970 he made about 50 handmade kits. Most of those don't exist. It wasn't for a few years that kit was commercially available and pushed out. The only reason I bring this up is kind of to give reference to where we are in the hobby, because anybody that flies helicopters knows that everything is attainable to us now. It's a click of a button. We order a kit, we order blades, we order our parts, we build a machine, we go fly it, we crash it, we order a parts kit or we order a new set of blades, and it's there and we're back up in the air. We are not tuning mechanical gyros, we are not wrapping and making our own blades. Everything is done for us, and really it has made this such an attainable hobby. I think the thing that keeps a lot of people again out of it is just the fact that they do crash, they do cost money to maintain. It does take a little mechanical capability to put them together, keep them in the air, put them back together when you crash them. But again, I think that if you go through the steps and you learn in the right way, those costs are extremely mitigated, and it can be a whole lot of fun to fly these models. I know that for me, it was something I always wanted to do, and a good friend actually offered one day to buddy box me on a helicopter. I had never flown a helicopter. I had come back to airplanes for a couple of years. He took me out to the field, put the machine up in the air, switched over control. I was able to kind of keep it in front of me and keep it facing the direction I wanted to. I did kind of, just like we all did, get a little happy, and it did kind of drift away, and then he was able to, take control and bring that back. And so there's a couple of things I want to recommend if you haven't flown helicopters. You're one of my airplane guys that are watching the video, and you kind of want to get into model helicopters. Reach out and get a buddy. Like, that is going to be critical. It is such an accessible hobby to us, but the learning side of it is steep. There are questions to answer. It's always best if you have someone in your local flying community, at your local field, that already flies helicopters, that's willing to reach out and help you. Those of you that are already helicopter pilots, if you've got a buddy that's looking to fly helicopters, take one of your machines, set it up, get it in a buddy box, and get them going. The only way for us to sustain this hobby is to grow this hobby, and that means bringing new pilots in every year, year after year, and doing our part to continue growing that. So one of the things to new pilots is find a buddy. The other thing that I cannot recommend enough, that was really recommended to me strongly, both by Danny and the guys in the helicopter community around me, and by the retailers around me, was to get a simulator. There's quite a few out there that work really well. I happen to use AccuRC. I love it. I like the mechanics. It works really well if you're already a Jeti pilot. So it's one of those things, it's just a really easy transition. If you're an airplane guy and you want to check out helicopters, you don't want to dive into money, get yourself a good sim, set it up on the Jeti, get it out there, and do some practice laps. And even if you're not going to move into flying helicopters, it can be a really good way to exercise your fingers. Gives you a good brain. The guys that are phenomenal helicopter pilots, I think they're like F1 pilots. I think they see a million steps ahead and they're able to recognize things. We're not all going to be 3D pilots. I'm not a great pilot. I know a lot of guys that aren't great pilots, but it's still a lot of fun to fly a helicopter. So I want to go ahead and show you a little video we put together, just a little appreciation video, show you some of the stuff that happens with model helicopters and the different kinds of flying that you'll see. Take a look at this and come back to me when we're done.
Alright, this is totally easy once you understand the physics. Watch this, left, yep, right, go back to the right, easy, you'll see a flip, 1, 2, 3, yeah, awesome!
How you doing, Mr. Ledbetter?
I'm Richard Ledbetter. I'm a docent at the National Air and Space Museum.
All right, so what do you have to show us today about how helicopters work?
Well, I guess what we're going to talk about is kind of the main rotor system on a conventional helicopter, and the main rotor system basically provides both the lift and the control for the helicopter. And how we control the helicopter is by varying the pitch at each of the rotor blades.
So how do you vary the pitch on a helicopter when it's rotating, when the blades are rotating?
We use, on most helicopters, we use something called a swash plate.
Okay.
And essentially what a swash plate does is it converts non-rotating to rotating control motion. We have two kinds of control for the helicopter, and for cyclic inputs, what happens is that swash plate will just simply rotate forward or rotate aft, and that changes the input to each of the rotor blades. But for collective pitch, what will happen is that swash plate will actually move up or down. That will actually change the pitch in both of those rotor blades at exactly the same time.
So in summary, there's three types of control. There's collective pitch, there is cyclic pitch, and then there's anti-torque. Of course, anti-torque is the rotor system on the back.
So let's start with collective, Carl. So what is this magical device right here?
This is the swash plate, and this is the source of all control for any helicopter. Any direction the swash plate moves, for the most part, the helicopter follows. So the collective is where you change the pitch of both blades, either up or down, and that pulls the helicopter up or down. You do not control the altitude of the helicopter by the speed of the blades. That stays the same.
It's translated up or down, and that controls how much of a bite of air the rotors take. Is that correct?
That is, absolutely. And that'll actually make the helicopter either go up or down. Or if it's upside down, it's backwards. The tail rotor, just like the main blades, never changes speed. So in order to control the thrust, we change the pitch on the blades so it can push or pull in both directions.
And the reason it does that, it's basically a reaction torque to what's going on up here. The blades are putting a torque into the body, is that correct?
Yep, the act of spinning the blades makes the helicopter want to go the opposite direction.
Makes sense. Can you show me what cyclic pitch looks like now?
Cyclic pitch is where the swash plate tilts and through the linkage controls the pitch of the blades and changes it every revolution to control the pitch and roll of the helicopter.
So that linkage rides on the swash plate and then pushes up on the side of the blade, and then that in turn changes the blade depending on where it is in the rotation of the rotor shaft, right?
Correct.
All right. And so what does that do for you?
That lets me flip it any way I want to.
That lets me do wizardry.
I don't know about you guys, but that last crash, like, that hurt my soul. That was terrible. I didn't talk about any of the different styles of helicopter flying, but there are quite a few things that you can get into, just like with fixed wing. You can get into the sport side, the aerobatic side, the scale side, and each one of those things, of course, has its own appeal. We want to get into a little bit of the heli programming. Actually, I'm going to walk you through start to finish on setting up the radio side of the programming. Again, there are going to be different steps at the end of this, depending on what flybarless system that you're setting up, or whether you're setting up an older flybarred machine, with just the tail gyro. Some of the things will change for that, but for the most part, a couple of cool things. Of course, you guys know we're Jeti, big pro Jeti house here, and most, if not all, of the largest flybarless controllers on the market are very easy to set up with Jeti. Most of them are integrated so that you can use our export protocol, EX Bus, to communicate with them. Setting those up is much easier for us to assist you with, because it is using our protocol language and it is stuff that we understand. So I am going to walk you through the first part of that, how to set the radio side up. There are a few things that each flybarless controller will require to be slightly different. If you're setting up a rescue system, or if you're setting up your switching may be different, you may get into some logical switching. If you have questions like that that are more specific or unique programming solutions that you're needing, you can always email those to me. I'm going to go ahead and give that out now. You can email those to me at james@esprittech.com. I've done a lot of those setups already and can usually get you right through them as far as the radio side of the setup to make the systems work the way you need to. So let's go ahead and jump into some programming. I'm going to have Jason go to the overhead camera. And let's go ahead and come in a little. We're going to do a little bit of moving on the camera just so I can make sure you guys see what I'm doing. How's that looking there, Jason? Okay, perfect. So we're going to start out by creating a new model. So we're going to go ahead and jump into the menu, our model menu, and we're going to select new model. We're just going to call this Heli. You're going to name it whatever you need to. I could have imported some of my own models for this, but I think it's better just to walk you through a new setup. Once the name's in, just click OK. We're going to go down and we're going to select Heli. We're going to click the enter button and move to the next. I'm going to continue to use this color profile and no image just to make it easier to see for you guys on the screen. Okay, when we get to basic properties, the first thing that you're going to select is the swash type. This is really going to depend on the machine, the machine that you're building or the machine you're setting up. If this is a flybarred machine using a tail gyro, you're going to use one of the servo position setups that are in the system. If this is a flybarless machine, where you're going to export serial protocol to the flybarless controller and let that do all of your cyclic and collective mixing, you're going to go ahead and select manual. So for this example, or mechanical, sorry, we're going to set this up as I would usually set up current machines. So we're going to choose mechanical for our swash type. We are going to choose governor no, because this is an electric, we're not using an external governor. Gyro 2, gyro 3, we can bypass or ignore those in this particular case. If you were setting up an older flybarless controller where you had needed to use our system to control output for your head and tail gyro separately, you could activate the gyro 2 and use that. But in this case, we're going to go ahead and move on to the next step. Here is where you would assign all of your controls to the various functions. We are flying mode 2, which is preset into the system for me, so all of my controls are already there. It does go ahead and put in a gyro sensitivity function and assign that to a 3 position switch on the transmitter. In this case, it's position SE. That is what you would use to set your 3 gain values for your export to the flybarless controller. With a lot of the modern controllers, a lot of what's going to happen is going to be at the controller level. Each one of those is going to require different signaling for changing between those modes or between those gyro settings. So some of those you will use the gyro sense menu, some of them you will not. Again, if you have a little deeper questions than that, I can help you research that if you're able to reach out to us here. But in this case, we're working on a typical pod and boom in our theoretical situation, so we're not going to add anything. If you were building scale and you were adding things like gear, lighting, functionality on the helicopter for scale detail, here is where you would add those. If you're a display machine and you want to run smoke on a fuel machine, you could add your smoke as a function. And here, of course, like anything we do in Jeti, you click the plus sign to add a function, you name that function and assign it a control. In the next tab we're going to go to is where you would assign the servos. All of those that appear in your function assignment menu will appear as we move forward by clicking the forward arrow into our servo assignment. Anything that's in our function assignment menu will automatically be set. If you need to move what goes out or what's exported on your serial stream, this is where you do that. So if your controller, for example, needed the pitch control on 5 and the yaw control on 4, you could simply scroll to those controls, change from pitch to yaw. We're going to scroll to number 5, change from yaw to pitch, and now we have matched the export from the radio to what the import requirements are for the flybarless controller. Some of those you're able to preset via the controller. Some of them are not, especially on some of the older controllers. They had very specific channel assignment requirements. So that's one of the things to verify with the manufacturer of the controller is what the channel assignment requirements are, and make sure you've matched those in the servo assignment tab on the transmitter. That way when you export that serial stream and start to set that machine up, all of the correct channels are being exported on the channels that are needed to match. So now that we have that set up, we're going to go ahead and click forward, create and activate model. Of course, if you've gotten everything right and you know you have, you'll click yes. It takes you immediately into servo setup screen. Typically, I'll just click OK and bypass that. That'll move us on into the heli tuning menu. In the heli tuning menu, here's where you kind of set up the specifics to a machine, and we'll go through some of that. The first tab is going to be flight modes. So if you click on flight modes, one of the nice things I think that Jeti did is immediately clicking into flight modes, it asks you if you want to create your idle 1, 2, 3 auto rotation and default. You click yes, it'll automatically lay those out in an order for you. Auto rotation, of course, is always going to be your primary, your number 1 flight mode. Everything below that defaults or defers to that first flight mode. That hierarchy is what allows you to, no matter what other mode or what other thing is happening, go into that hold or auto rotation mode. So the one thing I do like to do, and it's just me, is I tend to move the flight modes so that it reads auto rotation, idle 1, idle 2, and idle 3. When it puts them in at 3, 2, 1. that bothers some strange sensibility in me, and I have to change it. Do what you will with that. Just like anything else, you can assign the switch to control the mode. For me, I usually set it up the same, so we're going to go ahead and flip the top front switch for our hold on and hold off and tell it OK. Now we can go ahead and scroll down through each of those and set our 3-position switch for our 3 idle speeds. So we're going to set our first, we're going to set our second, and we're going to scroll down and set our third. So now as we scroll through the switches, you'll see that the check marks go through idle 1, 2, and 3, and hold on and off. So you'll notice at the top of the screen, you probably can't read it in your screen, but on your transmitter you'll notice that each of the flight modes is displayed at the top of the screen. You can verify functionality by flipping through the 3 flight modes to where it tells you idle 1, 2, and 3, and no matter what flight mode you're in, if you flip that hold button, you will see auto rotation replace that flight mode at the top of the screen. That tells you that hierarchy is intact and it is working. Once you have that set, you can move on and you can go into your function curves. 2 function curves in helicopters are pitch and throttle curves. I typically, in the machines I've set up, run a linear throttle pitch, letting everything default to the controller. Throttle curves is the one thing that, of course, you will need to set up. So if you click on throttle curves, you'll notice that auto rotation automatically sets the value for that curve at the bottom at -100. So we'll go ahead and flip out of auto rotation. We're going to go to our idle 1, and we're going to choose a constant curve. You can set that if you are one of the pilots that likes to set the machine up with a linear curve in your idle 1 or your idle up mode. You can leave that as a standard curve. That'll give you throttle control and pitch control on that stick. That is initially how I set my machines up, so that I had throttle control and pitch control on P4 when I was in idle 1. Very quickly I moved away from that and went to a constant curve in all 3 of my flight modes. So we're going to go ahead and set that up with a constant curve for our idle 1. You do that by changing the curve type by selecting on the curve type, selecting constant, moving the 3D wheel so that you can go over to the actual curve, and you click on the curve, and you can turn your 3D scroll wheel to set that to a position you would like. So we're going to go ahead and choose 70, 90, and 100 for our throttle curve. So you do that by simply changing from one flight mode to the next and repeating the process. Change it to constant and dial that curve up to an acceptable value. Matter of fact, let's go 70, 85, and we will choose 95 for our flight mode 3, idle up 3. And it's just as simple as that. So now as you scroll through, you can verify that by clicking OK. From the Heli tuning menu, if you click function button 2 at the bottom of the screen, it corresponds to your receiver outputs, and you can take a look at your throttle screen and take a look at what the percentage is on the screen. That'll indicate what's being output to your controller. You can also flip your hold and verify that it does go to -100 on the throttle line, and you're not seeing anything else happen. So far everything looks fantastic, and our programming is doing what it's supposed to. The last thing in our Heli tuning menu is our gyro settings tab. This is where you can actually set up your gains, your head gain, to the flight mode. So if you want to increase or decrease gain along with the flight modes, you can do this very easily by going to, and there's 2 ways to do this, so let's back up a little. You can set this up on a 3-position switch. so that adjusting the gyro settings is putting out 3 different signals as required by some of the flight controllers. You can use this tab as well as just your gain setting tied to the flight controller. You can set that up on a 3-position switch, or if you desire to set that up based on your flight modes, you can do that by changing the end of the line, sorry about that, where it says G, simply change that to S. Now it will allow you to assign a unique setting or output setting for each of your flight modes. Again, this is going to depend on what control system you're using. Just like in an aircraft gyro or a fixed wing gyro, this system or this gyro settings menu only applies to specific controllers and does different things depending which controller you're going to use it for. If the gyro you're using does use the gyro settings menu, the gyro sensitivity tab or function, you would want to set that up here for whatever method worked best for the controller that you're using. Once you've done these things and gotten this set up, done, you can go ahead and click OK. The model in the radio is now created. This is your basic helicopter model. From here, you would go into the steps required by the individual controller. If that was, say, a Bavarian Demon Axon or a Brain 2 or Icon 2, Spirit Flybarless system, all of these systems are integrated. At this point, you would go ahead and connect those systems using the EX bus output on the Jeti receiver, exporting EX bus protocol, and you would start to set up the controller and meet the needs of the controller at that point. Once you have the radio portion finished, the initial controller setup done, then you can start adding your cyclic servos, tail servo, and start getting the machine tuned in. This is the easy step. Unfortunately, that is the little bit bigger step for you, and there is a little more work on that side, and each one varies. If we have the ability, I do want to let you guys know. Jason, you can go ahead and come back to main. I want to let you know that if we have the ability, one of the things we'd like to do is start doing some smaller videos or short live streams in between as we get our hands on some of this equipment, and actually you'll watch me go through a basic setup on these different control systems. So I know a lot of the questions I get refer to third-party devices, and hey, I'm stuck at this step. Yes, I can jump online and pull the manual and we work it out together, but I do want to provide you guys with a little bit of video setup for some of the more popular controllers. So if there are certain ones you guys want to see and you want to see us cover, make sure you shoot us an email and say, here's what I'm using, here's what's always a problem, or here's what I'm stuck on, and we'll see if we can get in there and kind of help you guys out with the setup on those. Do a video, even if it's just a short one, just to show you what we find and what it takes me to go through this setup. I'm glad you guys joined us this week. I'm going to go ahead and take just a quick second and look through. We got... Okay, so Derek made a good note here that some of the flight controllers with onboard govs require use of 5 or 7-point throttle curve. That is correct, and of course, just like we did the throttle curve to constant, you would just set that at 5, 7, or 9 point and adjust each of the points. Derek, thanks for making that point. I've got some support there for the flight simulator. Again, like biggest tip ever that anybody ever gave me, and the one thing that kept me from spending a whole lot of money on machines. Michael, I like that. Actually, I read a ton about the Jet Ranger that you put in here. One of the early machines that followed directly after Sluter was Cavan with their machines. And it looks like nobody has any real questions on there, so we're going to go ahead and wrap this up. Anything that does pop up or comes to mind after I'm off or on, you say, we wanted to ask.